Hello, Matt G4IYT here, and today we're looking at the full mock examination number 1, version 1.6, and we are up to question 11, which reads, on applying a constant voltage V to a resistor-capacitor series combination, the current I, A, falls from an initial value equal to V over R towards 0, B is always equal to 0, C is initially 0 and rises to a value equal to V over R, or D may be calculated by Ohm's law and is constant. Well, all we know is we've got this resistor-capacitor series combination, but we can actually just draw out a circuit and analyse what it does. So flip over to here, and let's draw ourselves a little battery. That's going to provide some current for the circuit, and then I'm just going to stick a little switch in here so we can simulate the circuit being turned on. And we're going to go down to our resistor-capacitor combination here. So we'll have our resistor, and then we have our capacitor, and then that's going to go back round to the battery. So we are talking about what happens when this switch is closed, and we don't worry about what happens when the switch is open. When the switch is closed, well, when the switch is open, we're going to have 9. Let's say we have 9 volts here. When the switch is closed, we then have a voltage of 9 volts here. And what's going on with this capacitor? Well, if we're starting to assume the capacitor is discharged, it's going to have 0 volts across it. Therefore, we're going to have 0 volts here. So we have a potential difference across this resistor. That means some current is going to flow. How much current is going to flow? Well, if you recall Ohm's law, V equals IR. Just make that an actual I, or as I like to draw it, you can draw it as the triangle like that. So V, I, and R. And you draw an X in there because you're multiplying, a line there because you divide. So I, the current here, is going to be equal to V over R. We don't actually have resistance here, so we'll just say it's V over R like that. And as current flows, that's going to start charging this capacitor. As the amount of charge in that capacitor accumulates, what's going to happen? Well, this 0 volts is then going to rise to maybe 1 volt, and then eventually 2 volts, and so on and so forth until it reaches the 9 volts. And as the voltage across this capacitor increases, it means that the voltage across this resistor will decrease. We've gone from 9 volts to 0 volts to 9 volts to 1 volt to 2 volts to 3 volts. And as the voltage part of our V over R equation increases, then the result, the I, is going to decrease. The amount of current decreases. So we could draw this as a graph, and we can say, well, we start with an initial V over R up here, V over R, and then as the capacitor starts to charge, the potential difference across the resistor decreases, therefore the amount of current going through it decreases, and we actually find, well, the curve probably looks a bit more like that. So we start from V over R, and then the current decreases and approaches 0 as the capacitor charges. So let's come back to our answers, and we'll start from the bottom. So option D may be calculated by Ohm's law. Well, that's sort of correct, and is constant. Well, we know that's not the case because we see that it's got a gradient to it, as we can see in our lovely graph. C is initially 0. No, that's incorrect. It's initially V over R. B is always equal to 0. That's also incorrect because it goes towards 0, but it starts at V over R. And we have option A, falls from an initial value equal to V over R towards 0, and that is in fact the correct answer. Let's go and take a look at the answer key, see what we've got, and I forgot to highlight it. Answer 11 is option A. So thank you very much. I'll see you for the next one.